Well, good evening, everyone. Welcome to the Motor Age TST webinar sponsored by PICO. I'm G. Trulia, the president of TST.
And I'm Pierre Respo, the vice president of TST.
And you notice we're in the same shirts for once, which is very unusual.
Which you might be able to get used to, or you might not. You know, we'll see.
All right. What can you do with your Labscope? Well, you can do a lot, and we're going to show you a lot. PICO is a great scope here. Tell them what happens.
Everything works. Yeah. Okay. So let's do our normal disclaimers. First of all, this is a live on a car webcast, and just like in the shop, stuff happens, and things like the clicker not working. You know,
and now it works. Look,
and now it works.
Forward,
yeah, of course.
backwards, who knows?
That said, just like you guys, we don't read the manuals. So
that's true.
So, you know, when we kind of go a little bit, you know, that's because of that. But we have a lot of experience too.
Right. We tried, obviously, I've had a PICO scope for years. We will be using 4 channels on the PICO. We're going to show you how to make money with it, what you need to do with the scope. It's a very good scope. This is the PICO Master Kit here, actually what we're kind of using. And again, we want to thank PICO for sponsoring this. It'd be a little different. Some guys get a little tired listening to Pierre and I. Usually we keep you on about an hour and a half or so. This is a 2-hour webinar to let you know up front. It will be on the Motor Age site where you signed up and on www.tstseminars.org. That's tstseminars.org. So you can check either place out. We'll have it up there for you. So what to expect, Pierre, from this? What do you expect?
Whether you're new to scope diagnostics or looking to expand your capabilities, this webinar will show you how to turn your Labscope into one of the most powerful tools in your shop.
And remember, guys, you got to dust the dust off these things and actually use them. And when you go, well, I don't really need a Labscope, I got a scan tool. But let me explain something to you. A scan tool only updates about 10 times a second. A meter, 40 times. This thing?
Millions of times.
Millions of times.
And on top of that, a scan tool only tells you what, you know, garbage in, garbage out, what the computer or what the car system saw from its own sensors. If something is wrong with one of those signals, the computer's going to give you the wrong information.
You bet. That's why it's always good to use the scope. So learn how to perform a wide range of high-value tests that dramatically speed up your diagnostic process and improve accuracy.
All right, we're going to do battery and starter testing, relative compression test, basically, and seeing what the voltages are, right? Sensor testing, actuator testing. We're going to do voltage, current, and pressure waveforms. Not every single possible system, but we're going to do an in-cylinder test.
Yeah, so we'll show you that here. And you know, one of the big things when it comes to using a scope, people get nervous. Always baseline at the battery. You may have a bad lead set, you may have a bad connection, and that leads into frustration, doesn't it?
Yes, and by the way, we had that when we were setting this up. We had a lead that wasn't connecting. It sure looked like it was connecting, but it wasn't. We were getting no signal.
Yeah.
So you got to check it. You got to double check it. And by the way, when he talked about dust, don't even let the dust settle on it.
Hell no.
Yeah, use it.
It's a good piece of equipment to use. Okay. So there's the PICO scope that we are using. You'll see it up on the car. And just like a meter, it gives you a voltage reading, right? But it does a little better. It acts like this recorder over here, right? That camera. So when you're looking at this ignition waveform, you could start to see a lot of different things. If we had a problem with the ignition waveform, we could look like right here and see our spark line, okay? If our spark line is too far tilted up, you could have a wide gap. Let me blow that up for you, okay? So right here at that spark line, if it was up higher, meaning not on this angle, but let's say follow my blue arrow, it's more up like this. You know, if it's more up like that, you could have a wide gap or a very lean mixture. Conversely, if it is down, You could have a closed gap or maybe carbon in the plug end, right? Or running very rich. So it's really important. And from here where we're triggering, right there, to here to the firing line, this is called the dwell section. Dwell is the amount of time that the coil is saturated before it fires the spark plug. And that's what this firing line is here.
And by the way, actually, can you put it back on us? Because I want to point to this. The line before the dwell line, before the computer grounded it, that'll tell you system voltage.
That's right.
It's not just system voltage, but voltage actually to the coil. You know it got, not only was the car charging, but the power was getting all the way to the ignition coil. You don't have to test the rest of that system. Also, when you're in the dwell time, in the part where the coil's being charged up, being energized, you know whether you have a ground there. You can blow that up. You can expand that to the point where you can see when you have some kind of computer strategy that is modulating. Sometimes they climb up after the coil is saturated.
It could also measure the time here.
And you can measure the time, how much it's saturating.
The 3 point something, actually 4 milliseconds.
Right.
So it is really important and really good to look at this. You know, ignition's only one of the things. And again, you can't catch everything with a meter or a scan tool. You know, a lot of people think if they graph on their scan tool, they're looking at a scope pattern. They're not. It's totally, totally different.
Don't get us wrong. Scan tools are wonderful.
Oh, yeah.
They're fantastic. But you do have to understand their limitations.
And remember, sometimes they could substitute a value where this, you're going to see the real thing.
Yeah.
Now, let's talk about the scope here a little bit, right? So you got a 10 by 10 screen. Now, I know it's a little tough to see those little lines.
You can't really see the grids.
background.
That's why Jerry put the numbers on there.
Okay, so if you look here, I mean, we could see them here. You could probably see them. And you'll see a PICO black screen as well. It depends how it looks. You just need to know the grids, usually 10 rows high. That's why we have it this way, 10 rows high and 10 rows horizontally, okay? Dividing the screen into 100 blocks called major divisions. Older scopes were only 8 high and 10 wide, divided into 80 blocks called major divisions.
Okay, and in digital scopes, where the grid is made of light segments or dots instead of painted on the glass screen, you may have the option of turning on the graticule, which is a, let's call it a magnifying glass, off and on to change the spacing and the number of lines or dots that make up the grid. Also, I want to say something about this. When Jerry was talking about making it black or white, that's an option in the scope. You can put it, they call it inverse video sometimes, or, you know, they've called it different things.
And it's in settings on the scope.
It's in the settings. So under certain lighting conditions, like this white screen out in the sunlight, might be a little hard to see. But if you inverse video it, reverse it, then it's easier to see. You can also change the colors of all the lines.
Which is nice. You know,
Yeah.
you want to be a purple guy for the day? Well,
Or whatever.
you can turn it to purple.
Yeah, yeah. And some of that has to do with ambient lighting. I mean, what's the lighting where you're working? Maybe you need a different color so you can see it.
You bet. Time and voltage on the scope here.
So, time is across the screen.
Horizontal.
Right? Horizontal across the screen. Voltage is up. Vertically.
Like us, for now we're vertical. Later,
Yeah, yeah.
who
And
knows?
if we can become horizontal, well, that's
It's not a good day.
that's the end of the webcast. So, but I want to say something else. When we're measuring other things, amperage or pressure or whatever, the time is not what changes. It's the vertical part. It's going to be amperage instead of voltage. It's going to be pressure instead of voltage.
And it would be the amplitude of the signal, the height.
Right. It's still, by the way, the scope only still sees voltage. We're using devices that convert whatever that other value is into voltage so the scope can see it. And then our software makes the adaptation to show us what the value is in amps or PSI or whatever it is we're measuring.
Yeah, that's a good point. So the scope is not taking amperage in where, you know, current could burn something out. It is using a steel bar with windings, AKA amp clamp, and converting everything from voltage into a current reading.
And actually, you know,
or pressure reading.
I want to point something out here because this is actually one of the neat things about this scope. Every other scope out there you have to have say a 9-volt battery on
And didn't we just come across a 9-volt battery? That was
we just
dead?
had a 9-volt battery on something.
Not on
that
the
was
PICO. You
no,
don't have
on
to
something
worry.
we were trying to, scam the system to use on the car. We didn't get it to work. The bottom line is, I'm a big 9-volt battery killer, right? You leave the switch on, or you put it in the box, and the switch gets hit. This scope automatic, if you use their probes, automatically powers the device, and also sets it up in your scope software so it knows what it is on that channel. Kind of a neat feature.
It is a very good feature. Very good. So when the scope is connected to a circuit, voltage in the circuit is displayed, as we said, vertically. Vertical movement indicates change in voltage. To measure voltage, count the number of divisions the trace rises, multiply it times by the voltage scale. So let's take a look at this. First of all, what type of signal are we looking at? What do you think this signal is? And please type in why you think this signal is whatever you say. So Pierre, we got to look at that chat. Dorian, can you move that chat box over a little bit?
And I'm going to just say, if you look, you have to look at the scale on the left to know what the numbers are.
Right. This is our scaling. And again, you could have made this any color you want. We decided to pick blue. So what type of signal is it is one question. And then what is the voltage value? Anyone yet?
No, but somebody asked for the downloadable handout. It's on the website, right?
Not up yet. It'll be there tomorrow.
Oh, so you'll have to wait till tomorrow to download the handout.
I made that
As
announcement.
well as the recording they could view.
Yeah, and the recording too.
So tomorrow morning it will be up.
Renee said, somebody said, Jimbo said analog. Somebody else said CAN. Somebody else said intake pressure pulse. And somebody else said CKP.
Okay, now, what type of signal CKP?
AC ripple, somebody has said as well.
Okay, so it's AC ripple. Now that's very good. Now it wouldn't be a CAN signal because you're going above and below zero here. See here, right about here is your zero line. Notice how we go up. So you take the positive peak, you're about maybe, and we're not using curses on it here, but somewhere about 2, and on the bottom, you're about 2.1.
Minus 2.1.
So that would be a peak to peak of a total of 4.1. Okay, that's how you would measure it. Now, vehicles like BMW have specifications on crank signals. If you don't reach a certain amplitude, a height of the signal, you're not going to get it to start.
Or we've had a couple of cases over the years where somebody swapped the wires and what I call the missing man gap went the wrong direction, and the car will never run that way. It does not identify that as a crank signal.
You know, we also had a good one on a Volvo. A friend of ours, John Anello, he went to a shop. They put the wrong flywheel in. So what happened is the teeth on the flywheel were too close to the crank sensor, making AC voltage too high, preventing the computer from starting up.
No, I think it was the opposite on that one. It would start and it reached a certain RPM and it would cut out and reboot
This was a
itself.
different one, 'cause
Oh,
I have
different one. Well, he's had a few of those.
He's had
John
a few.
actually has had a bunch of that kind of problem.
But again, if the amplitude is too high, it's like, you know, when you have your battery charger on, right? Yeah. The ripple of a battery charger, AC rides on DC. So you don't want to have too much AC voltage, because if you're trying to program a vehicle, that can give you a problem as well, right?
Yeah, of course.
So this is an
They don't
AC
like that.
signal. So if you got that right, that is good. Now here, time per division. Now you can see the nice black screen here on PICO. So you could change it. I changed it over. You see it a little better. You know, it's a little bit different as you're looking there. Look at our colors of the channels. Blue, red, green, yellow. You can make them any color you want. That doesn't matter. But you have those 10 by 10 boxes. You could see here we got the voltage on the side. So if you picked 2 volts per division, you go up, you would have 20 volts per screen, right? 10 times that amount.
And obviously you set those things based on whatever it is you're testing. If you're testing something that's a 12, 14 volt system and it's not going to go above that, you only need 20 volts. You're within
Exactly.
but if you're doing an ignition coil or a fuel injector that has a big spike at the end of when it collapses that field, then you need more. And you need the attenuator on the scope.
While he's mentioning that, so if you're on anything that's going to go over 200 volts, you want to put in your attenuator. The attenuator could either be a 10 to 1 or 20 to 1. We'll show you later when we go live on the scope where and how to select it. That protects the scope from any high spikes coming in to burn that channel out. So don't just hook up to ignition, whether it be primary or secondary, because the inductive kick can get very high.
Actually, I'm gonna put a caveat there, because we say this almost on every webcast. Look at the wiring diagram first and see what you're dealing with. That ignition coil may only have a 5-volt signal going to it.
A lot of new ones. Yes.
And you're okay with a regular old non-attenuated lead. But if you don't go to the wiring diagram,
you won't know.
You don't know that.
Yeah.
And actually system operation too.
Yeah, no doubt. Now, the other thing is, if you're on a coil like that, what do you expect to see? Because there's two different types. If you have more than 2 wires, you're not going to see an ignition pattern that we just seen back here. Let me just get back to that for a second. You're not going to see that. That's primary ignition that basically is on a 2-wire type of coil.
Actually, Jerry, can you blow up just this part of it?
Sure.
Or actually, no, the whole dwell time. So, if you had a 5-volt, for example, square wave trigger for that coil, the module, the ignition module, is in the coil. And the square wave is going to go up to its 5 volts and over and down just as it fires. That's the dwell time.
That's right.
But all you're going to see is a square wave.
It's going to look totally different. So on vehicles that have the module built in, which a lot of the new ones do, you could make a set of ignition wires up, and if you had secondary leads, go on the ignition wire with the coil out here, and you clamp the wire here, you could get a reading. We used to do that on old GM Quad 4s, on old Saabs, and any other vehicle that would have that type of setup. So that is all doable.
Now, I'm going to say, like this car we're going to work on in a little while, it's a Ford with what I call a fold-over intake manifold. You can't reach the back of that motor.
Not at all.
You're never going to do that on the back of that motor because it's underneath the manifold, right? So
but you could find your primary up at the computer, right?
Yeah.
And that's where you would want to go. Always go to the easiest spot. And here's another little tip. When you're trying to set up a scope, and there's many presets, we'll show you that as well. One good thing about PICO software, it is made for automotive, and they have a lot of automotive setups on a lot of things. You want to know how to get on that ignition signal, you want to get on that fuel injector. It could preset the scope for you. But here's the thing to remember. How much voltage is going to a fuel injector? KOEO, 12 volts or so, right?
Running 14
or so, right? So you're going to have to set it up to at least that per division. Because what are they doing? It's going to be 10 times that amount on the spike. So if you selected 10 volts per division, that's going to be 10 by 10, 100 volts per screen. Does that make sense? If you're on a crank sensor square wave, well, it's a 5-volt signal. You're not going to pick 100. It's going to be real small.
Right.
The higher the voltage, the smaller the signal. The lower the voltage, the bigger the signal.
And the same is true with time.
You bet.
If you have we were just playing before, with a CAN signal, for example, you don't need a lot of time because it's a very fast signal. If you put it too much time on there, it's going to alias. It's going to look like garbage. Same is true in the opposite. If you want to watch, say, an oxy sensor sweeping up and down now, you need hundreds of milliseconds, seconds, to get a pattern out of that.
Correct.
So yeah, you're going to have to play with it, obviously. And we're going to do a lot of that when we get on the car.
Yep. So here's more information here on that 2 volts, doing a count up, going across. If you had 10 milliseconds on the bottom, 10 times 10, it would give you the total setup. So the scope is set to 2 volts per division, 10 milliseconds. We have to set the ground level at 0 at the horizontal grid line above the graticule. That's right here, okay? The bottom is shown on the dotted line. The waveform rises 3 divisions from the ground line. So 1, 2, 3, right? So by 2 volts per division, how much is that line? A 6-volt square wave. And then if you take the time, 10 times 10 is 100 milliseconds of time. If you wanted to measure out the bottom, that's ground when it's on to when it's off and comes down, that's a complete cycle. You would then go from here to here, and that would be 4 milliseconds of time for a complete cycle.
It was 10 per, right? So it was 20 milliseconds. Sorry.
20 milliseconds.
And this,
yeah.
on this drawing.
Sorry.
The bottom line is you have to add whatever the time per division is and multiply it times the number of divisions you're using.
Correct. Very good.
And when it's fractions, that's where we use cursors and let the software. You can say, oh, that looks like about something, but if you want to get accurate, you're going to put the cursors on it and see what it is exactly. Little box is going to show up, tell you what the exact number is.
Right. I mean, I'm not a big cursor guy, and we're not talking about the S and B words. We're talking about
cursors
on there, you know, and to see what it is. I could eyeball it because why? We have these grid lines, right? We have those lines that if we know what we have the scope set up at, and again, go back here to the black scope, if we have this set up at 10 milliseconds, so from here and there, there's 10, 20, it's not rocket science, it's pretty easy. So just know how to set your scope up. Okay, so trigger, now this one, not if you're old enough like Pierre and I, not Roy Rogers' trigger, right? Not that horsey.
That was a horse. For all of you who don't know who Roy Rogers was.
We date ourselves. Okay?
Yeah, that's right.
But trigger is super important if you want a steady look at the signal. Now, my opinion is that if you want to know what the signature of the signal is, you select, okay? You select trigger. Now, we're going to show you 2 different things here. So notice if you trigger on a positive slope, that means you're going to go from low to high. And here's where my trigger is, right there. Okay? Now, if you trigger on a downward slope, negative, you see where my trigger is? Now, here's what you get to see. The beauty of, hey, is my charging system working? Am I going to ground? And another good thing when you're on a scope, never put the pattern all the way at the bottom. Why? Because it may go underground and you have a problem that you're not going to see.
So what he's talking about, for those of you who aren't familiar with it, is that, say that actuator, that fuel injector, may only go to ground, but the circuit might be impacted by, say, ignition leakage from a coil problem or a spark plug or a wire problem, and it's feeding a spike, a negative spike into the whole car. And you'll have a negative spike somewhere, a bunch of them, somewhere there, and if you put that 0 on the ground, you're never going to see it.
You're never going to catch it. I always like being at least 1 box up or 1 division up from the bottom, as you can see here. So you got that place. If something went down here or went down here, you'd be able to see it. The difference is, so it went down here or went down there. The difference is where this is triggering. Okay? So you don't want to trigger on something that's going to go on the falling edge, okay? So positive trigger is meaning you're going to go from low to high. Negative trigger, the slope is going to go, from low to high.
Now,
Okay.
I'm going to say something else here. Doreen's going to switch over to the other view. When you have, this is kind of experience that you have to play with, right? If I like to start out with the bigger picture, I like to start out maybe not even triggered, but I want to see a lot of time. I want to get an idea what the larger pattern is, and then I start bringing the time down less time, bigger picture, more clear picture, so I understand if something erratic is going on. And then I'll trigger. So that's one of the tricks of trigger. You want to trigger on something that's stable. If you have, say, an ignition and you go on the spike, but the spike's higher and lower, you're going to have an intermittent trigger event, and it's going to confuse you.
Right, and it's called walking. So if you get something that's kind of blipping across your screen, that's called walking across the screen in Labscope land, you don't have your trigger adjusted to the right level. So again, trigger gives you a picture. Now, if you take the trigger way off, you know, we're going to show you a couple of different things here that you could do on a scope. If you're triggering at a level, let's say higher or lower, you're not going to get a picture. That ain't going to be good, right?
Actually, you know, we should explain what trigger really is.
Oh, right here.
Trigger is...
Trigger is the function.
Trigger, yeah.
Its name suggests.
That's
right. It triggers a scope sweep when the signal crosses a specific voltage. But when we could also set the scope up to trigger on either rising or falling edges.
The point is, it only starts, it's always looking at the signal, but it only draws the signal when that signal crosses the trigger. That's the point I wanted to make. The scope sees the information, but you don't see the information unless the trigger makes it draw it on the screen.
Right, unless you're untriggered,
yeah,
and then you'll see some blips going across.
And it'll go
and
crazy.
It's better to start looking like that, in all honesty, than bring it in. Now, once you have what I call signature here, once I'm looking at a fuel injector, you're, in most cases, not going to see a dropout. I like to do this. I like to make it a picket fence. So now all of that gets crushed up, and we'll show you that a bit later. And then when you have a little hole in between it, that's when it dropped out. That is the best way to find if you have something cutting out. Because when you're looking at it like this triggered, it's at a certain time frame, right? When you have more things happening in a sample, you're going to see if something falls out.
And unfortunately, the human eye isn't that fast.
Oh, come on. My eyeballs, what are you kidding?
And this thing is very fast.
Very fast.
So we miss things. You know, if the frame rate is above what our eye speed can pick up, you're going to miss it.
You bet. So here, there's internal triggers, what we use on all scopes. This is a sample of the voltage of the scope triggering right here on a fuel injector. And if you remember, well, if you're young, you don't even know what this thing is. This is called a timing light. This was called external trigger. Now, there are some things we still can external trigger on, okay? We could use a clamp on ignition if we wanted. You wanted to put something on a coil, like the PICO pad, and you wanted to see if it was number one or trigger off that. Yeah, you could do that. That is an external trigger. That's not internal trigger. Internal is using the trigger in the scope.
The signal itself, yes.
Yeah. Okay, so here is all the trigger modes we talked about. Now, you could have none. You could have auto. Now, auto, I only like if you're lost in the sauce and you're doing one channel. If you're doing multiple channels and trying to pick auto, it's probably only going to pick one signal or so up unless it's in the same time frame.
And by the way, it can be confusing, especially when you have a lot of very different signals.
Yeah, especially if you're on 4 channels.
Yep.
Repeat. Repeat means you want it to keep running.
It's going to trigger a sweep. When it gets to the end of the sweep, the next time the trigger event happens, it's going to sweep again. It's going to overwrite the original sweep with the next one.
Right. And if you didn't save the screen,
yep, you lost it.
You lost it, okay.
And single is it's going to do the sweep.
And lock it.
And then it stops. It stops right there. Single sweep. And you can, in fact, we set it up yesterday. We did it. I don't know if we'll do it today. We did it with our relative compression test where I had it set for a amperage level that was higher than the regular cranking amperage, but at the insurge amperage, the initial spike. So it would only trigger once, because you only turn the key once. And then it stops when it reaches the end of the screen, and you could go have a cup of coffee. That information is still going to be on the screen when you come back.
Yeah. So these are some of the things that you can do there. And you can trigger, you know, again, none, automatic, repeat, or signal, and take it from there. All right, let's talk about the throttle position sensor. Well, you know, you're going Humpty Dumpty here, up and down, right? You should go from a low voltage to a high voltage. Now, when you're doing that, you have to have your scope set up. Number one, how much voltage goes to a throttle position sensor? Well, 5 volts. So
8
what are we
volts,
gonna pick
12
here?
volts?
So you see what we did? We picked 10 volts.
Right.
You could have picked 5, but what happens if it goes over 5, you may miss it, or it may cut the end off. And again, I want to say this once again. If it's too small, the voltage is too high, lower the voltage. If it's too wide, you can close it up, add more.
Make it faster, right?
Make it
Now,
faster.
I'm going to say this because this is valuable for contemporary cars. We have 2 throttle position sensors, don't we? We have, and there's 2 different strategies. We have the ones that one of them does this,
And one does the opposite.
and one does the opposite, or in pedal position, but sometimes they do it in throttles. One is 50% of the other.
Correct.
So in that case, I started with this, didn't I? Read the wiring diagram. Maybe you use 2 channels on both signals, because if you have a throttle position code and you only look at one signal, you might be on the wrong one.
And by the way, sometimes you could have 2 TPS, or TPs as they call them, and 2 APPs, accelerated pedal position. So again, like Pierre said, read the diagram. If you don't RTFI, and if you don't understand what's going on, read the freaking information. It'll save you a lot of time and make it easy. And by the way, the worst time to use any tool, never mind a scope, is when you're having a problem, but you never used it before.
And it's an emergency and the phone's ringing and people are driving you crazy. That's not the time to do it.
Go take the time, as like you're watching this, go hook up to a vehicle tomorrow or later or whatever, and we know it's Saturday, so you probably won't do it later, but play with it, practice with it. That old saying, practice makes perfect. You will get really good at it. Both Pierre and I have been jerking with scopes.
Decades.
Decades.
Absolutely decades.
Okay.
And by the way, on top of that, where do you measure? Do you measure at the throttle? What has to be getting the signal? It's the computer. So I always start, you know, some people will say go to the device. I say, you know, that kind of depends. Is the computer hard to reach? Yeah, I'm kind of lazy. If I can reach the throttle and the computer is under a floorboard or something, yeah, I'm going to start at the sensor.
Or if it's the upside down ones in some
Yeah,
of the
that
Euros.
are hard to reach. But as a rule, if it's easy enough, I want to get that signal at the computer, because if it's bad, I can always go back to the actual device to see if it's bad there too.
Right.
If it's bad there too, it's a problem in the throttle or the power ground to the throttle. But if it's not bad there, what if it's good at the throttle but bad at the computer? Now you got a wiring problem.
Yeah, you may have VD.
Yeah,
No, not
voltage
that
drop.
type.
No,
Yeah.
not that one that you're thinking of. Voltage drop.
You bet. and that's pretty common.
Yeah.
But if you can always test at the easiest place first. But if you can get to the computer, you know, like we'll show you on this Ford product, they made it nice and easy.
It's
right
perfect.
under the hood.
In front of you.
In front of you. Now, do you have to go through a lot of little dopey wires there and kind of back probe, and don't pierce wires? Not a good idea, right? Don't do that. Okay.
Yeah. By the way, if you're then find that you have a bad signal and it's bad, you know, at the device, then you should be checking powers and grounds to that device, and that you should do at the device first.
Right. You can check if you have 5 volts and if you have ground.
Right.
Remember, a voltage drop, it's all kind of easy to figure. If I'm supposed to have 5 volts, Pierre, and I have 4, well, it's a voltage drop of 1 volt, right? But if I'm supposed to have 0 and I have 890 millivolts, okay, that means it's not pulling down to ground.
That means you have almost 900 millivolts, pretty close to a volt of what we call float, right?
Right. And
Floating
not
ground.
good. Not good at all. Questions?
Why isn't piercing good?
Okay, now, see, we live here in New York.
Rustland.
So If you're in the real world, not some places where it's like,
Sunny,
you know,
and dry.
Arizona and dry and there's no humidity, you know, you won't have as much of a problem. But if you don't use a Hickman probe, a real small one, and you're using a piercing type of pin, let's say that little wire, right? How many strands are you going to break? What flows through the wire is current. And if you break the strands, it's not going to be good.
On top of that, and I know we always say to cover it with nail polish or
Yeah.
brush on electrical tape and all of that, but it doesn't always seal the wound properly.
That's right.
And we live in the land of salt, and the worst thing is that brine, which is
Oh,
not just
terrible.
regular salt, but it's potassium or magnesium chloride, not sodium chloride, and that stuff is caustic.
Yes.
It eats everything.
It's bad. So
Kills the plants.
if you're going to do something like that, and a Hickman probe, is a very, very small, super fine little needle that if it's on a new wire, once it goes in and comes out, you can't even find where it did it. Now, why is that? Well, on a new wire, the insulation will sort of seal itself.
It's kind of flexible.
It's flexible, but come on, we don't get cars that are flexible,
No.
especially in the aftermarket world, right?
They're old and the
They
insulation's
got
hard as a
heat,
rock.
They got cold. They
Yeah.
got dirt. They got all this crap going on underneath there.
And maybe
correct?
somebody washed it with something nasty and hardened up the plastic even more, or the rubber.
You mean they did an engine wash?
Yeah,
Or
with
brake
something
clean
with
it?
something nasty. Yeah, right.
Oh, that'll be real brutal. But here's what I'd suggest. The two things to do that if you ever did, which I don't recommend, liquid tape is one way to seal it good, not nail polish. That's BS. And you make sure you clean the wire area first so the liquid tape would definitely stick. And the 3M vulcanizing tape that you'll never get the hell off. So once you put it on, you better make sure you want it on there because it is like a tire patch that's not coming out. Okay? Those are two good
if you don't
ways.
know what he's talking about, this is a tape that it's not sticky, but you cut a piece and you stretch it to activate the chemical process and you wrap it over itself and it turns into a solid piece of rubber. It vulcanizes to itself.
Yeah, you
solid
can't get it
rubber.
off.
Well, you can, but you'll probably ruin the wire doing it.
Yeah. Another question?
Yeah, can you say the same of the probe again, like Hitchman probe?
Hickman, I always get the name wrong. It's one of them, Hickman.
It has a very fine
It's-
needle, and it doesn't tend to cut the wires.
And by the way, it will cost you about $50. Okay. Look for it online, and it is super small, yellow and red. And when you open it up, you go, is there something in there? You know, at my age, I need the magnifying glass to see
or a
it there.
microscope, maybe. You never
Yeah,
know.
it's pretty small. That's what I'd recommend. Any other Pearson pins, I'm not a fan of. Back probe pins, let's talk about them for a minute. Now again, in the area out here, you know, or Midwest and all that, when you try to get that back probe pin in to the wire harness or the connector, well, those things are all hard. I suggest use a back probe pin and use a little silicone on it so it could sort of slide in.
Lubricate it.
You don't lubricate and you start jerking around and trying to get it in there, you're going to ruin that weather seal,
And
aren't
now
you?
on this car here, which is a 2012, first of all, most of the stuff doesn't have weather pack connectors on it, and we are able to back probe with the regular pin set that comes with the scope, and we don't have a problem. But you get on a really new car with weather pack or really small wires, you're going to need something finer than a regular back probe pin. You're going to need something that's a really fine needle. There's a lot of stuff out there. But you got to look at your connector. What you don't want to do is either punch the needle into the wire or punch the needle into the connector and flare it out and ruin it.
Very good. Any other questions before we move on? Okay, so throttle position, voltage corresponds with the throttle opening. You know, you go from low to high, it should go all the way up if you went pedal to the metal. And remember, you're not going to get really 5 volts, you may get 4, 8, or whatever.
And you're not going to go to 0. You might get 0.6 or whatever it is, but you also don't want to see a dropout.
Like right here, if you get a dropout, remember, even little Mrs. Jones, she's going to go driving to church real slow. She ain't driving like Pierre and I, and we go 0 to 60.
And we have a reputation, you know.
We like driving fast.
That gas pedal's there for a reason, you know.
All right. Now, this waveform, a mass airflow sensor, actually grams of air coming through, are going to be measured. It's going to be low in most cases, and as more grams of air come through, it's going to go up. If we have a problem with that mass airflow sensor, if it's a dirty wire type, a bad digital type, digital would be a square wave. You would see something that maybe wouldn't look really well, or it's dropping out. Remember, picket fence, you got a hole right there. That's where you would set your scope up and start to play with the time frame. Once you see signature, tighten it up. Tighten it up, because that's where it's going to grab.
I call it the missing man. Look for the missing man.
That is a goodie, okay? So obviously the signal increases to indicate an increase in mass air taken into the engine as the throttle opens. And by the way, you could use 2 channels. Watch if you had throttle right here and mass air, they should go up at about the same time. And a lot of times here you can get a little dip because of 14.7 pounds of pressure, so we don't float around like space people, right? You're going to see that little dip there depending on the particular vehicle you're on.
And by the way, the same idea applies to map sensors, right? Because they're a load sensor as well.
Right. And by the way, there are 2 very important sensors that you really should scope. Now, map sensors usually have 3 wires. Ford likes using a digital map sensor, 159 hertz, plus or minus 6, so 165, 153. Okay, that's at sea level. You live in Breckenridge, Colorado, near 9,000 feet or so. Well, you're going to have to do an adjustment on those numbers. It's always good to know your barometric pressure. And if it's a digital signal, it does not need to go through an A to D converter. Someone said analog signals prior. This is analog. Computer don't read analog. It reads zeros and ones. So it goes through an analog to digital converter. And then in that big encyclopedia, it's like Pierre's head, for Christ's sake, right? Got a lot of info in there.
I think it has even more head than my head has.
But remember, the computer is only as smart as what's programmed in it. And nowadays with OTA, you guys know what OTA is? That's over-the-air updates. So
Yeah.
they
So
do these all the time.
Tonight, your car could have one version of its software, and tomorrow or Monday, it could have a different version.
You bet. Now, I love when my Lightning gets an update. I thought someone was robbing my vehicle. I happen to look at my security camera.
All the lights are going nutty.
The thing's all lit up. It looks like, Will Robinson, we're in trouble. I thought it was lost in space. It's crazy. Okay, so here we're looking at a standard fuel injector. And it's pretty easy. Again, you could come out one division or so. But what is, and this is important, it's like a nice to know and a need to know. What is, on a good running motor, okay, good running motor.
A hot motor at
hot,
a regular idle.
Regular idle. What is the on time, the normal on time on a good running motor of a saturated drive injector like we're looking at? That means it's not a peak and hold, it's not a pulse modulated.
And we're definitely not talking about GDI.
Not yet.
We're talking
I'm gonna show you
about
that.
port injection.
What do you got?
I got 3 MS, 2.3 to 3.5, we got 5.
That was a number we used to see. 3 to 5 is kind of what we say
Very
today.
good.
But that 2.3 to 3.5 kind of used to be a number. That that was.
And you still
was
can see it.
you can
Depends
see it
on the
sometimes,
model
yeah.
year vehicle.
So yeah,
Very
those are all
good.
good answers. Yep.
Good answers, guys. And here, again, on time is measured from the drop right here to here, depending on how you have your scope set up. Also, what about this peak? What's the minimum voltage on the peak on a saturated drive injector? Now, there's a lot of VD going on with this, because remember the old injectors, all the Bosch ones, the clips were a pain and you'd pull it off and
People
clip
used to
went
break
flying.
them all the time.
Right.
Yeah, I used to carry a whole box of spares.
And if the gasket was gone, you need to put some dielectric in there, because what's going to happen, you're going to get corrosion.
In the land of rust.
Now, and by the way, there are many companies now selling ends, so you could cut, solder, and heat shrink a new end on, which is kind of nice.
Yeah.
Okay.
I get all different answers.
So what do we have there? I can't see that far away. How much voltage? The peak, minimal?
30 kV,
How much?
30,
Okay, anyone else?
12 volts,
12 volts. No, the peak got to be more, but it's okay if you get the wrong answer.
80,
80.
Actually, it
Okay.
was a little bit of a trick question because
Minimum, we said minimum.
Minimum. So some of them clip, some computers clip it at like 40 volts, but mostly I think that 80 is a good number. Minimum's probably 60, right? But
No,
80,
minimum's 35.
Oh, yeah.
Minimum's 35. Now, the reason why I bring that up, if you don't see at least 35 volts on his peak, you may have VD.
Yeah.
Meaning you have a voltage drop, power or ground, don't matter what side, but you need a minimal of 35 volts. Many get up to 100 volts. And then if it's clipped by either a diode or a resistor, however they want to do it, they're going to limit that to keep it a bit lower.
And by the way, when you do this and you blow this up, so you're just looking at that peak, if it's clipped, it's going to have a square top.
That's right.
You can see that. It's not pointing anymore.
And look at this one. Here we're 60-something.
Right.
See, I don't need a cursor on that, but you could pop the cursors on and see where it's at, okay? Now, let's look at voltage and amperage. Now, one thing here, Pierre, what's real important when we're going to do voltage and amperage? The setup we have right here.
What's most important is that you have them on, next to each other, but also you're going to look for an amperage that's not excessive. If you have too much amperage, now this is an injector, not a coil. Coils
Let's
have
blow
more.
that up.
Yeah. And around an amp is kind of the number. You don't want to be much, what it was a 1 point, what do you have that as a number?
1.2 is the max.
Yeah. So around my kind of rough number is around an amp. If I see around an amp and they're all the same on the same motor, then that's good.
Right.
If you have one that's dramatically less, we may have a voltage drop problem or some other winding problem in the injector. Or if it's more, we could have a short somewhere. We could have some slightly melted windings, and that's the kind of stuff that cooks computers.
Yes. So right here, the other thing is make sure you're on the same cylinder. So if I'm doing
that's
cylinder
what you
1 and I'm on cylinder 3, you're not seeing like we have here. And notice what I really like, as voltage drops, you see the blue line going down? What happened to amperage? Amperage rose. What's this little round thing right there? What's that? Don't tell them yet, Pierre. What's that little round thing right there? Right where my point is at. What's that?
Pintle?
Yes.
Good. That is the
right.
pintle bump. Now, how many of you own Noid lights? I'll sell you mine, by the way. Noid lights are garbage. When you use a Noid light, to think that you're really getting fuel, you're not. Because how many milliamps does it take to operate a Noid light? A couple of hundred.
Right.
200 to 300 max. How many milliamps does it take for the pintle to open so fuel could spray in?
900,
600 or
yeah,
so.
whatever,
Look.
700, 800, yeah,
Look,
whatever it is.
right here. Oh, I got to move that over.
Oh, okay.
Okay. So look at our chart. Okay, here's 0. We're about an amp, and it's about 60%. So if you're not getting at least 600 milliamps, that Noid light is garbage. Throw it out because it'll give you a false indication that the computer is grounding that injector and it's getting the right power to give you that fuel spraying in there. So Noid lights are not good. You need to start using a scope. And this scope is easy to use. You could look at it real quick. And don't be afraid to save screenshots. Give them to the customers. That's what we do here. And we're going to show you a couple of things on a car in a couple of minutes. The stuff that you should do every time you do a diag minimal. And if you have time and you want to sell work, never mind about using your fancy battery tester thing. Start doing it with a scope. You do it with a scope, you're using 2 channels that we're going to show you in a few minutes. It's not hard to do.
No.
Okay? So watch what we're going to show you. Any questions on this? Okay, now let's move over to a GDI injector. Now what do you know about a GDI injector? First of all, you see this peak right here? It's going to be 65 volts. Why is it 65 volts? My car is not a hybrid. It's not some crazy type of electric vehicle. It is basically taking the system voltage from the battery, 12, 13, depending on the particular battery in the car, and it is boosting the voltage up inside to 65 volts. Why do we need 65 volts? We have an increase in pressure, don't we?
And they have to move very fast.
Super fast. And why do we need that increase in pressure? Well, guess what? We have to overcome compression of the cylinder. So here we're showing you the voltage, and notice once it does that, it gets down to about 12 volts, and what's it doing? It's duty cycling, isn't it? It's duty cycling.
And that's the amperage.
And look at the amperage. Now, notice we're at 0, so we have an amp clamp, and by the way, we should have said that before. When you hook up, not only are you on the same cylinder injector, but you're on the negative to get voltage, the negative wire, meaning the ground wire, and then you're going to be on the other wire, or either wire with the amp clamp, don't matter.
So
current is the same in a circuit.
Current is universal in a circuit, but voltage obviously it changes in different parts of the circuit.
So here, as the voltage went up, okay, or went down actually, the amperage, what happens here? Starts coming up. What's our peak amperage? Well, I eyeball it, it's about 12 and a half, 13, comes down here to a state of about usually 6 amps or so. And that's the on time. You see what they're doing here? They're duty cycling it. Okay, they're duty cycling it. So it is good to put a scope on there and see what you're doing. It's not that hard to do. And there are plenty of GDI injectors that I've come across that are bad. They could be a piezo type, meaning they got to be coated to go into the cylinder.
Welcome to my world.
Yeah. Or they could be a standard one, but know that you can get readings on these.
And by the way, they are playing with both the positive and the negative side of these injectors. So I like to use current as my kind of primary visual for what the injector's doing.
Yeah, it's a very good idea. And by the way, you could also do it on the fuel pump. We didn't show you that here, but you can go to the fuel pump. It's a 2-wire solenoid for the high pressure pump we're talking about. And of course, you could do your low pressure pump, current ramp that. You know, if you do 30 and 87 on a relay, you could jump them and put an amp clamp there and current ramp your fuel pump.
And see what it's taking. And look at the waveform, by the way.
Okay, so here we got a few different things. What we have is a AC crank sensor, that's this here. And notice the amplitude is roughly, probably 4 volts, okay? And then we got a CAN signal, CAN high, pin what? What pin is CAN high? Let's see, you type that in, pin high, and pin low, okay?
14, 6,
6 and 14 are the two of them, yeah.
That's the 2 numbers, but which one's the high one?
6.
Good, very good. And then we got ignition. Here's our dwell time. And we can see right here, look at the firing line.
And by the way, look at that. That's like a double bump on that ignition, right?
Ah, see, now that's a good set of eyes. A double bump. Now, why would they have 2 shots right here? You got 2 firing lines happening. Why would they use that? Now, many manufacturers did use this, but why would they do that? Why would they go like this?
And
Why
where
would they bang it
would
twice?
they do? When would they do it?
That's a good one. Let's see, type that in, please.
Multi-strike.
What is it? I'm sorry?
Multi-strike.
Multi-strike, excellent, excellent. Multi-strike sometimes 2 to 3 times. They're gonna fire the plug. For what purpose now? What purpose would they fire that plug multiple times? And when? Because Pierre asked when.
Because I had to throw that into the mix to keep your brains working here.
Emissions. To
It's-
make a more complete burn for emissions.
That's
Good.
correct, yes.
That is correct.
So they only do it around idle, and
Oh,
it's for
give the
emissions.
answer already.
Oh, sorry. I wasn't supposed to tell you that. I'm sorry.
But it's okay. So for emissions at idle, once you get off idle, you're not going to see the double or triple bump.
Right.
It won't be there. Very good. Excellent. Okay, so what do we have here? This is a DC signal. And what are we actually looking at here? Okay.
And while you're thinking
It
about
shows you
that,
current draw, but what are we looking at?
while you're looking at that, somebody asked a question, how do you measure amperage on a fuel pump? And the answer, by the way, I don't only measure the amperage at the fuel pump. I put 3 channels on it. I put a channel on the positive side, I put a channel on the negative side, and then I put an amp clamp around one of those 2 wires to the pump. And so now what I'm seeing is and I try to do it, you can't always reach the pump, right? But as close to the pump as I can get, because now you know if you have voltage drop going to the pump, you know if you have a floating ground voltage drop on the ground side, and then you see the amperage, but you can also see the waveform and see if you have a commutator problem, a brush problem. This is on a brush type pump I'm talking
There
about.
are brushless pumps too.
Yeah, and there's 3-phase pumps
Yep.
now. So
Yep.
we're not getting into that for that, but technically you could, even on a 3-phase pump, you're really not going to be putting the amp clamp around the wires. They're twisted and you don't want to screw with that. But if you put the amp clamp around the power wire to the module, yes, I know the module takes some electricity and all of that, but you're going to get a good read for what that pump is drawing. You got to subtract a little in your head for what everything else is taking.
Excellent. Any other questions? Very good. So
All right.
here we basically have a peak amperage going up. And what else is it showing us here? What else are we looking at? Take a peek at that. It's nice and blown up. What else are we looking at here? So you can see what your starter is pulling. Didn't give you numbers, don't matter.
Not for this test.
Initial rush is always going to be
It says relative
the highest
compression.
current. Very good. Relative compression. So here we basically have a solenoid coming on, 0 amps, then we come on. We see that little bit there, goes up to the highest peak. That's the inrush, and here we level out is our relative compression.
And actually somebody said that, inrush followed by the compression.
Very
Yep.
good. Excellent. And what are we looking at here? And this is something that you could buy extra on a PICO kit.
Cylinder?
It's in cylinder.
Yes.
Now you may go, well, I don't need that. I got my gauge, my compression gauge for years. Well, I'm going to tell you, you definitely do need it.
You could buy my compression gauge too, because I never use the thing.
And it's the same way you did compression, okay, with the exception you have to take the Schrader out. If you did running compression, the Schrader valve would be at the end of the hole. We're going to do in-cylinder pressure transducer on this vehicle, but don't be afraid of it. It's basically going in and giving you a better reading. If you got DOD, displacement on demand, or Chrysler MDS, or any of those systems that cut cylinders out, they're very difficult to actually take a regular compression reading and see if you got a problem. When you're dealing with a scope, think of it like the MRI into the electrical system and the engine. So it is way better to do this. You could see if you have a problem with valves. You can see what your peak compression is.
I'm going to say this. If you look at this waveform, and it's got, I don't know what that is, but let's say 130 or 40 PSI at the peak. We didn't put a cursor on it.
Right here.
But
you're about I'd say about 170, 160 something.
Okay.
There it is.
the bottom line is that this waveform is a cranking compression, right? This is not a running relative compression or running in cylinder compression.
Right. Cranking.
This pattern is normal for cranking. If you saw this pattern on a running engine, boy, you got a problem.
That you would.
In fact, that cylinder really isn't running.
Yeah. So you got to pick the pepper out of the fly dough, right? All right, let's take a peek at another one here. So here's relative compression, voltage, and amperage. And this is our ignition. And you could put numbers up here to see what each one is actually doing. The red is the amperage, the blue is the voltage, and the yellow is ignition. So when you clear flood the vehicle, go ahead, Pierre, tell them. When you
Okay,
clear
so
flood,
when you clear flood this Ford, I'm going to say this because other cars don't operate like this. In fact,
That's right.
actually, you know, from my BMW world, I wish, are you listening, BMW? Put clear flood in your cars, please.
It's only about 85% of the cars have clear flood.
But the bottom line is, on this Ford, when you clear flood, the ignition, the injectors aren't the only thing that are stopped. The ignition is stopped. There's no ignition going on while you're clear flooding. Jerry was on the scope, and I was inside the car with this, right? So you energize the ignition switch, you hit the key, it's got inrush, it pulled a lot of current and then settled down as the engine started spinning, but I was in clear flood, so it's not starting. I took my foot off the gas pedal, it fired up, it started firing the ignition coils, and you're watching negative current because we had it set up so it would show positive for current going out of the battery. Now you're recharging the battery. You know, there are some purists out there who would say that this should have been down and this should have been up. And you know what?
Doesn't matter.
Yeah, tomato, I don't care.
And look at it. So as amperage went up, voltage went down. You could kind of see some compression. And look, when they both started, the amperage, as Pierre said, went negative to show you it's charging up. And what happened to the voltage? The voltage jumped up.
Yeah.
And then leveled out. They both kind of popped out at the same time. Okay? So that is pretty good. That gives you where are we hooked is always a question I get. Okay. So the blue is positive and negative leads at the battery.
On the battery.
Okay. The gold or yellow is at the primary negative wire of the coil.
And
okay?
we're lazy, so we picked the one that was easiest to reach. It was number 1 cylinder on this car.
Of course. We got to be super lazy.
You got to be lazy, right? So that was number 1 because it was easy. Has a fold-over manifold, but that was the easiest coil to put the wire on.
And where did we get the red?
Around, it could be either battery wire,
Correct.
either one. And again, what's the easiest one to reach? Now, again,
And around all the cables.
I was just about to say, I'm a BMW guy, and we tend to have like a block of stuff with a bunch of wires, and it's hard to do on the positive side. But
You
we
mean
tend to,
over-engineered German stuff?
yeah, with a bunch of fuses in that module. But on the negative side, we usually just have one wire. This car has 2, but they're right on next to each other. So I did the negative side because it was easier.
Yeah, and that's the way to do it. Always do easy.
Yeah.
Okay, here we got ignition and running compression.
Right.
So explain, Pierre. We'll blow it up a bit.
Now, by the way, normally we would want to see, actually maybe put the camera on me so I can just use my finger instead of Jerry's pointer. We have a compression stroke here. And normally if we were on the cylinder, if our ignition was on the same cylinder as we were measuring compression, this ignition would be just before TDC. It would be, I mean, actually there are some conditions where it might be a little retarded from TDC, but usually it's advanced. This is because we were on a different cylinder because, well, you know what? I'm lazy and it was easier. So we were on cylinder 6 for compression, but cylinder 1 for the coil.
Correct.
So that's why this is not just before TDC for this cylinder. But you see all the little bumps here? Each one of those is from a different cylinder firing.
Those are the little bumps he's talking about right there.
Yeah. And so we're not firing the bump before this TDC because guess what? The coil was disconnected. There's no little bump there. The bottom line is you could look at timing issues. You know, if somebody had a messed up flywheel and some kind of a cam crank correlation code or something like that, and you put we're going to get into cursors later a little bit, but if you put your cursors on it and each one of those wasn't equally spaced, you might have a problem with your reluctor wheel or that something is messing with the signal, noise
Correct.
on the signal. So, but this is all very good for analysis. You can really get a good picture of what the motor's doing. And actually, before we stop, and this is a running compression, a healthy running compression picture. It's got a compression peak, which is, you're going to hear different people say it differently. Some people say 50% of cranking compression. I'm going to say I have a wider window, 40 to 60 in my head.
Because it depends on the motor.
And that's assuming you have a normal idle. If you just started this and it's revving at 1700 RPM, these numbers aren't correct anymore.
Correct.
But you're going to see 40 to 60% for the compression peak. You're going to see vacuum at the bottom of the exhaust pocket, the same vacuum you had on the intake stroke. You're going to see, right, that's vacuum. You're going to see a defined valve opening event. You're going to see atmospheric pressure here. If you have something like BMW's strategy, and other manufacturers do it too, where you have a little bump at the end of the exhaust stroke, that's because they have what I call natural or forced EGR. It's
Scavenging it out.
It's making a little back pressure so they don't need a real EGR system to keep some of the exhaust gases in there so they can reduce NOx. And if you have a real lot, then you've got a problem. You're not opening. You have exhaust blockage. I do not call this a plugged cat. I call this failure to exhaust, because there's other ways it can fail to exhaust. But if you have carbon, a melted cat, a muffler problem,
a pipe bend.
somebody put the gasket in backwards and it's blocking the exhaust port, or a problem with a lifter that's partially collapsed and it's not opening the valve all the way.
Ooh.
Yep. There you go. Bottom line is, then we have, you usually can't really see overlap exactly, but at the point where it dives for the floor, I know two things. I know that the intake valve is opened and the exhaust valve is closed. And because that dive for the floor, which happens at the 360 mark, the piston is not moving. It's near the top, but the crank is rotating near the top, which means that's all because the intake valve is open, it's exposed to the intake manifold, there's vacuum in the intake manifold, and it sucks it down to vacuum.
Yeah.
Yep.
And you got your other peak.
And then you suck in the air and you compress it again. Do the same thing again.
All right.
All right.
Here. What happened here, Pierre?
Wait a minute. Somebody asked a question. Have a PICO 7. I didn't understand the volts per division in the beginning. Right now in relative compression, channel A is set at 20 volts. That means each division is, no, that's 20 volts per division. But you're on the wrong scale because we're on PSI for the, if you're looking at the 20 volts, that's our, we have 200 volts on that.
That's 200 volts.
Because we're doing ignition and we have a big tail on it.
Right there. We have the attenuator 20 to 1.
We used an attenuator because you don't want to smoke the scope.
Yeah, remember we said that early. When you're dealing with any high voltage over 200 volts, you need to use the attenuator. The one that came with this kit is a 20 to 1. You could use 10 to 1. They sell both of them.
Jerry,
you got
maybe
to
you
set
should
it up.
magnify this so they can see where it is
Sure.
on the scope. So you see that says scope B, which we're not using, would be a 1X probe. It's just 1 to 1. But channel A is DC 20 to 1. So it's important. And plus or minus 200, it's 200 volt range for the entire screen, 20 volts per division
Right.
individually. So that's important stuff there, right?
And here's the pressure transducer.
Right.
That is telling you
I did zero it.
500 to 0.
Because we had a problem when we first did this test. Our scaling was all wrong, and I said, oh, we have to zero the transducer. Okay.
And there's your 1 second division.
Yep.
Okay. And there's your trigger at 40 volts. So that's the setup. Hopefully that takes the confusion out of it.
But if not, ask away, because that's what we're here for.
And then let's explain, Pierre, here the waveform.
Okay. So this is, again, started cranking it. Now, we didn't use clear flood here. Think of these, there's a drop here as it started to move the crankshaft and started to run a breathing cycle, a fire cycle, but it's not firing yet. These two spikes here are before any ignition or injectors opened, and therefore, and they're barely cranking. So this is the highest compression, right? Because the engine's barely running.
Yeah, you're at
It's
160.
Yeah,
something.
that's like a cranking compression number because it is cranking and it hasn't fired yet. And now we start to fire, and we'll see our ignition events, but you'll also notice that the compression goes down and up again. And the reason it went down and up again is because the engine kind of was going slow and then started speeding up. It would be like a cold idle. If you let this run long enough, you would see it taper down to whatever the hot idle speed was. We didn't put all that on the screen, but that's what you would see.
Yeah.
So that's what it is.
Perfect. Now we can get onto the vehicle.
All right.
All right, so we're going to switch over.
And actually, Jerry, I'm going to say this so everybody else hears it too. I think I zeroed this probe, but let's double check that because I might not. You want me to do it?
All right. Got to put some glasses on here.
Yeah, yes.
Where do you need this? Underneath the
Initially, I think we just underneath the hood, yeah, because we're going to kind of show where we are at, and I'll point to things.
hood? Okay.
We got that. Zeroed.
So we're going to do this a little teeny bit differently than we did it in those slides. Those slides were done exactly this way yesterday and today. And while Jerry's doing that, actually, Doreen, maybe switch to the camera and I can show them everything. Okay. So we have the big amp clamp that came with the kit, right? Like 2,000 amp clamp, big monster. All right. It was zeroed because you always, here's what we always teach. You put the amp clamp with the jaws closed near the wire you're going to test and you zero it. Now the reason for that is you are zeroing out for any electromagnetic fields that may be around this area. So what does an amp clamp do? It looks for the electromagnetic field that current going through a wire creates. It's measuring that magnetic field, it's responding to it with its little ferrite core and its windings, turning it into a voltage and sending the voltage to the scope so we can display it as an amperage. So zero it, which we already did.
I just did again.
Did it again, good.
And I'll just show them where it is when she switches
And
back.
you put it around. Now, if I had this the other way, or we hit invert in the program, it would be the way I told you the so-called purists would do. But I'm me, and I think like an old automotive tech, and this is the way I'm going to do it.
Okay, so here on the clamp on channel C, you can see the clamp is selected right here. Watch my cursor. And we zeroed it close to it for the magnetic field.
I think we're on B, actually, with the amp clamp. B.
It says here.
Yeah, well, the wire's on B. Did I screw that up?
It says you're on C.
I can swap the wires since I did this, so it's my mistake.
No, attenuator. C is the attenuator.
Attenuator, that's on the ignition, yes.
That's ignition.
Yeah.
All right. A is on the battery, I believe. And I zeroed all of these.
20 actually, D is on the battery. A is on the crank signal, which is something we added from when we were doing it yesterday.
All right, so we're all set here. But here's when we went to go on the zeroing. We went to probes. You can see the 20 to 1 here, or 10 to 1 that we discussed. When you look at the amp clamp, here's the amp clamp. It's telling you plus or minus 500. When Pierre took the clamp and put it near it, I had hit the 0. So we're pretty much all ready to go.
And by the way, I did 500 because we already know that the inrush is kind of close to that. If you put it at 1,000, then the whole waveform will be kind of small and a little harder to read. And if you put it at 200, you're going to miss the spike.
And we're not triggered on anything unless you want to trigger on something. So we have none.
I did trigger it yesterday. We can do it that way. So I triggered it at like 200 amps on the amp clamp channel.
And that's
channel
on
B.
Right.
That's what I did yesterday. That way I could go, because Jerry was, putting together all the materials
You want
for this.
repeat or single?
Single. Let's do single.
Okay.
So what's going to happen is Jerry won't have to touch the scope. He won't have to. As soon as he hits the run button, it won't do anything until it sees 200 amps.
So I'm going to make it 200 amps. There
Actually,
we go.
and tell me when you're ready, because I'll get in the car.
Yep, go ahead.
So now I'm going to kind of do the same test. I'm going to clear flood it at first. And then, oh, actually, what's our time base on that, our time, Jerry?
We got 20 milliseconds. I should go more.
Oh, yeah, you need 2 seconds per division.
Yeah, 2 seconds, you're good.
Yeah, okay.
Ready?
All right, so I'm going to go now. I'm going to clear flood it first, and then I'm going to lift off the gas pedal, and it'll start. And that's all we should need.
That's it.
And you see, it looks all compressed, doesn't it? Because maybe we should have had 1 second per division. But it doesn't matter, because you can expand that. So there you go. You can expand it.
You can see here's our cranking compression. And here's the blue is the crank sensor.
Yep.
The yellow
The yellow's on the battery,
battery. So it's our battery voltage. And if you
I think.
come over.
Yeah, yellow's on the battery.
Yep. And you can see like a little drop right there. We go back.
So you can measure the current that the starter motor is taking, the mechanical, not only capacity, the drag on the starter motor that each cylinder produces, but you can see if they're even with each other, right? You're looking to see if they're even with each other. And Jerry's going to manipulate that. There's lots of manipulations you can do with it.
I was just going to grab this right here.
Right, the inrush, the beginning. So that's kind of
missed it.
yeah, but that's okay. You get the idea, because there's only like 4 bumps there, and it's still kind of speeding up. But each one of those, so that is current, right? Which means that every time it goes up, the engine slowed down. That was a compression stroke. Where the voltage for the same thing goes down for each one of those. So what you're looking for, once it's more stable, and maybe I should have kept it in clear flood a little longer.
We can redo it.
Yeah, you want to redo it?
Yeah, I'm going to make it 1 second per division.
Yeah, do that. And I'll do a little more clear flood, and I'll do a little more running, because that was kind of quick.
Yeah, I'll tell you one, let it clear out.
Okay, we ready to go?
Go ahead. Beautiful. Beautiful.
Okay. Yeah, that's better. Or as my college-educated daughter would say, more betterer. That's just to insult me for all that money I spent. So
I love it.
yeah, she does that on purpose. Okay, so.
And look at our starter solenoid right here.
Yep, you can
look
see.
At the voltage as amperage went up. Look at it, how the voltage went down in the yellow. And there's the peak really went up there.
Yep.
Kind of cut it off at 500. Okay. So you can see everything, and there's your crank sensor. All good.
That's right. And of course, maybe draw a box around the cranking compression before it started, type of thing, just to show the uniformity.
Cranking compression.
You're gonna have to go back out and just pick a different part of it.
Okay. You want me to get right here? We're here.
No, actually, over like here before it fired up the
Okay,
engine.
so right about here.
Yeah, we're stable. I just want to show the stability of it all.
Do you want me to get into it too, like this? Or you want
Yeah,
me to
maybe
stay-
give it a little of the actual running too. But
Okay.
yeah, there. That's what I was trying to show. So if you look at that, you see how uniform this engine is? all the cylinders are identical. But if you had one, if you have a misfire,
It'll be the odd man out.
and you have a misfire and some other shop just put plugs and coils and all kinds of other garbage in it, and one of those is low, you got a mechanical motor problem and they wasted somebody's money, and you don't want to be that guy who wastes that money. So whenever I have a misfire, I don't care what the other codes are. I'm doing a mechanical engine check like this.
And this is what you guys should be really doing. You know, it's not hard to do. Again, maybe you don't have to go to the crank sensor.
No,
but
I added that.
Just go on the battery, right? And you would have the red and the yellow to show you the voltage and the amperage.
And if you had a car that doesn't kill the ignition, you would also know which cylinder is screwed up.
Yeah, good point.
You know, you can do your firing order and you'll tell which cylinder is screwed up.
All right.
So there you go. All right.
So this could be your battery starter test. You know, if we, I don't know if, let's see if you could turn off blue. Let me see if we can turn that off. Okay, so I took blue out of the way. I'm going to take green out of the way. So here is your starter and your voltage.
Yeah, right. Current and voltage.
And if you look at that, you can see as they dissect each other right there. And of course, the more you want to see, all you got to do is here's your compression. Let's cut into that. And again, it's just two leads, one for the amp clamp, one for the voltage.
Now, we're not kind of doing this here because we already did it earlier, but I'm going to say this because it's like a mantra. And it's not because I've gotten old and senile and forgetting what I'm saying. When we test components like that TPS or whatever, or, you know, throttle, powers and grounds. When we test something like this, anything on the scope, save the data before you manipulate it. First thing you should be doing is saving the data, because if your computer dies, which it, by the way, did on me yesterday when we were doing this, because I was plugged into a drop light to power it up that wasn't feeding the computer or anything. But anyway, the bottom line is you don't want to lose your data. I'm kind of old and impatient, and I don't like to do things twice. So save the data right away. Then you can do two things. Number one, you can walk away. You can shut the computer off. Somebody else could take that computer and do something else, and you haven't lost your information.
Correct.
But also, you kind of know where you were, right?
All right. What are we going to connect?
Since we don't want to get into the spark plug quite yet,
No, we'll do that near the end.
I think
you want to
we-
do the mass airflow sensor?
we could do that, or we could do CAN, whatever you want.
We'll do CAN near the end.
So
Let's
we're kind of
take-
done with ignition at this point, right?
Yeah. Yep.
So give us a minute, guys, because we have to kind of switch things around here.
You want the camera, you guys?
You could be if you want to, you know.
Want to see
We'll
us?
try not to embarrass ourselves too much. And
Want to move stuff around?
actually, it's hard for us to embarrass ourselves because, you know, it's just not how we are. So I am on one CAN high, I think. What is that? No, that's 6. Yeah, that's CAN high, right?
Yeah. You want to give
And
me
I-
another one for?
And I'm
CAN
going to
one?
give you, I guess, yellow, which
Or
is...
you want the crank? I could take the crank out, or give me the yellow. Don't
I'll
matter.
give you the yellow because you're already there.
I'll
Just
take that off.
Yep. So so just so you know, we have an extension wire from the DLC coming out and to a DLC breakout box here. Normally you wouldn't do it that way because, you know, you're working in the car, but we want to show it to you. So that's what we're doing. Now, Jerry's going to show you this. Actually, should I put a scan tool on this to make it activity?
If you want. All right, so I'm going to be setting up to do CAN here. So let me get out of this. We're going to go, he said he's on yellow and red. So we're going to go to yellow. We're going to drop that voltage down. What voltage do you think we should do? 5 volts, 10 volts? You want me to plug that in, Pierre? I can plug it in for you.
Yeah, if you can reach it easier.
Somebody wants you to show how to hook it up.
So put the camera on it. Okay. So we have a DLC breakout box here. You're just going to have to trust us that those are pins 6 and 14. But they have banana plugs on these DLC breakout boxes, which is the same plugs that the test leads have. So it's very easy to just plug into the DLC breakout box with them.
Right. And now I'm setting up the scope on both channels. I'll go to 10 volts just in case. I'm going to take the trigger off. I'm going to put none on the trigger for now. And I'm going to put the yellow channel on 10 volts as well. This way we could see it, our scaling here on the side of 10 and 10 over here.
Now I'm going to turn on the ignition. This is where we kind of should have had a power supply on it, but
I'm going to change the time frame.
we won't do this for too long.
You could see a blob.
So if there was something, the voltage was 12 volts or short at the ground, you'd see that. But you're not going to see individual packets there. It's too much, right? The scope is too slow, not fast enough. You have to set it for a faster speed. And I don't know why this is, oh, there we
It'll
go.
come on. Slap,
Yeah.
it up.
I wasn't paying attention.
A normal ID.
I don't know why it doesn't like us. I'm going to have to pick it manually. For some reason, it's not IDing.
You could hear it beeping on and off. And you can see when I separate this.
It's asking me a bunch of questions, so while he's playing, it's making me, play, does it have this or does it not have that type of thing? Okay. So now I'm about to hit the button for a all-season fault scan, basically what BMW laughingly calls the short test, even though it's not.
It's a very long test.
Yes. And while that's happening, you see how the picture changed on the data? It actually changes what it shows you on the CAN bus data because the scan tool is asking the car for information and the car is responding. Now you can get into the whole geeky thing of what this is, and I think that's way beyond the purview of what we're doing tonight. But the idea is we know a bunch of things. We know, first of all, that CAN is in the correct voltage range. We know that we have data being transferred back and forth. So we don't have a problem. And actually, there are codes in a few modules because this is a car that they put a motor in and it's been sitting out in the parking lot. And, and it's got some low pressure tire warnings and all kinds of stuff going on. So, but, it's our guinea pig tonight, right?
And you could hear it even when it beeps. Look at the signal. Look what's happening to the signal.
Yeah, it kind of speeds up and slows down. It changes what it's doing.
See what happens when you hit a clear. Is it done doing its thing?
Yes, it is. You want me to clear everything?
Clear all.
Okay. So I've just hit quick erase, which is also not quick, but we all know this, right? We see this stuff every day. They use these words.
Like dropping down, and the beeps change. You should be able to hear the beeps.
And so this is doing a full system clear, except that, guess what? We still have 3 modules that are red. But that's because this is a car that's, like I said, the guinea pig tonight. So that's all CAN is. And again, you're really, the first thing we look for is a short to voltage or a short to ground or CAN high is not doing what CAN low is doing.
Right, and notice them if I freeze it. You notice they all look the same?
They're mirrors.
That's when it's cleared out. It's a mirror of it, isn't it?
In fact,
that's down, that's up, that's
the CAN
down, that's
is
up.
an additive communication protocol. Can high and can low being opposite of each other, they have to add up. So there's a 1 volt up and a 1 volt down. They have to add up to the 2 volts. So if you have something like a floating ground or something that's only affecting one side of that, or you have any kind of interference that's interfering with that, it'll mess you up. You have a question, Dorian?
Could you show a quick setup for CAN decoder?
You want to do the
We're
CAN
not gonna get
decoder?
into
I don't. I would like to do that, but I think we're going to run out of time if we do that. There is a CAN. If you look on the scope menu, there's a CAN decoder on the left side. You could pick it off, but that's like another 2-hour seminar. And I would like to do that. I really wish. I mean, maybe tell us. Maybe it's something we should do in the future. So CAN decoder. So there are different. Even though we call them CAN, there are different CAN speeds and different generations, and so you have to decode it based on the individual rules of that particular CAN version, let's call it. And so there is actually a bit of work to do to make sure that you're decoding it properly and getting messages.
Yeah,
But
see, like here, I use it something quick. It's a sample rate too low. I'd have to jerk with it.
yeah, you have to play with it, right?
All right, let's move on to the mass airflow sensor.
Okay, actually I can get out of this, right?
Yeah, you can get that. I'm going to get that beeping off because it's,
Yeah, because it's annoying.
it's driving me crazy.
Right.
I want to show that someone wants you to show the actual lead hookups, including the ground.
Ground is on the engine.
So I'm going to.
It's a good engine ground. They wouldn't be able to see it.
Well, I'm going to tell you what it is on the camera, but you're not going to be able to see it really. Just switch to the camera now. So we ran all the grounds to a ground lug that's on the side of the motor here, but you can't see it. It's down here. So you really want to be grounded there or on battery negative, right? That's the best ground, battery negative. And we were there, we still are there for the original test with the amp clamp. But all these things, because we were working over on the other side of the engine, and somehow the idea of putting wires through fan belts is not appealing to us. We decided to keep it all on one side so we wouldn't mess anything up here.
And this is a main ground.
Yeah, it's a main
So
ground.
always go to the main ground.
It's got a big ground on the motor. Yeah.
And if you looked here, we were on pin 6 and 14. So that's right here.
And actually, I should probably turn the ignition off so we're not. Somehow, one of the faults in this car is that it won't turn the blower motor off.
Yeah, it needs a blow motor.
And as a result, key on engine off, we're sucking juice out of the battery.
And then it'll be our luck, it'll die right in the middle
of the seminar.
We got to
right?
throw the charger back on.
Right.
Okay, so the next thing.
What do you want? In cylinder? Or you wanted mass air or?
Yeah, let's do the mass air.
Let's do mass
sensor.
air. Okay.
We'll go on yellow.
So actually, let's do 2 because I don't remember which one's which, and one was temperature and one was.
Where's the other wire? I just gave it to you. Red.
Yep. And I did this yesterday, and I kind of forgot which one's which. So we'll be on voltage. It's not a high voltage. You could have, you could have 10 or 20 volts, and you'd be fine. If it's only a 5 volt or an 8 volt, whatever, I don't even know what this is on this. Is it a frequency? It's a frequency based, right?
Maybe analog on this one.
Bottom line, low enough voltage will be fine. It'll give us a pattern. We can play with the time if we don't like what we see, right? Now, if we had the scan tool on it and we wanted to listen to the beeping, we could compare the mass air number in our data stream to the output of the actual sensor and see if they followed correctly. Because, we talk about this a lot of times, if you're in OBD2, you will have a real value. But if you're in your factory level software and you have a problem with a signal, they could be putting a substituted signal in there. And that's why you want to read the actual sensor, right? So you don't go down the wrong path with that. All right, should I fire it
I'm
up?
still setting. Hang on.
All right, I'm going to turn on.
Would you not advise the breakout box ground? Is that not advisable?
Well,
that is the breakout box ground. You're going through the diagnostic link connector. Okay.
So you're trusting that
and
ground to be
trusting
good.
That ground, is it really good? No. I would definitely want to go to the engine ground. Now,
so-
that's not to say you can't do relative compression off pin 4, which is chassis ground, and pin 16, which is battery power. But when you're dealing with a lot of stuff that we're testing, a good ground, the best ground is obviously, like Pierre said, the battery ground. Nothing better. Okay.
And the second best, what if you have one of those products, I'm not going to mention a brand, that they put the battery under the stupid driver's seat?
I know those people.
Yeah, we all do. Or even actually one of my BMWs where it's a wagon and the battery's in the trunk, but they bolted all kinds of crap on top of it, and it's a pain in the neck to reach.
Very tough.
Bottom line is, yeah, you really want to be on battery negative, but like we've said many times already, we're kind of lazy, and we go for the next best thing.
Yeah.
In this case, the battery's right here. We have a battery ground right here. It's great, except that we didn't want to twirl any wires up into the pulley or anything, or whatever, burn it on the manifold.
All right, let's start with the mass air.
Okay, so we're going to fire it up.
Wrong one, Pierre.
Yeah, I always do that, don't I?
Mark
That's the right
fan.
one. Sorry. So just so you know, when he said wrong one, Pierre, I was trying to turn on the fan, not turn off the light.
Pierre, you have the red and the yellow, right?
Yeah. And they're supposed to be, let me rev it a little bit because there's a lot of noise in that.
Yeah, I'm going to try to clean that up.
And then I'll rev it. One of those is just air temperature. I just don't know which one's which because I didn't memorize it and I did it yesterday. Bottom
we
line
got about
is the
4
one that
volts.
changes when I rev it is the mass air, and the other one's the temperature.
All right, good. Rev it.
There you go. Red is mass air.
Yeah. So the red is the mass airflow center.
Yep. Now it is a noisy signal. We're probably oversampling it a little bit. But it's okay. You can see that it's going up and down. We're not actually setting a code for that. Ooh.
We slow the time up.
And now you can get that picket fence. If there was a dropout, there'd be a hole in that signal. Now again, this could be smoothed to look prettier, but already we can see that we have a signal that's doing what it's supposed to do. All right, I can turn it off, right, Jerry?
We're getting a lot of noise on it.
Yeah, it's a noisy signal. And we could use smoothing. We could change the frequency that it's looking at to smooth that out.
Yeah, someone said you could save the raw data and then apply the filtering.
Yeah, we can filter it. That's correct. We
Right.
can do all that, yeah.
All right, let's use the amp clamp. What's the back there? The fuel injector? The black
so
one?
this is the fuel injector, number 1 fuel injector.
And we're
and
going
the
to put the
black
red
one-
wire?
So what we're going to do is we're going to put one wire on it.
Let's use the red one.
Actually, let's use the green one because I already have the attenuator
Okay.
on it.
Let me pull that out of the ignition.
And then I'll put the low amp clamp around the wire.
Yeah, you give me that. We'll zero it. So green, I got to put the green channel on.
Yep. And I go around this wire. Actually, we're going to zero it near its spot, but I got to find the end of the wire so I can actually hook it up. So, you know, you got to understand, guys, we set all this stuff up.
Oh, you have
And-
the attenuator on the green, right?
I have the attenuator
21.
on the green. And I don't,
What's this not working?
we don't,
Come on. Green, channel manual. We got probe,
okay, I'm going to
20
be,
to 1.
I'm going to be on blue with the amp clamp.
blue with the amp clamp. Okay. Yeah, it came up automatically, guys. 2
Yeah.
amp.
So this is what I was
I'm gonna
talking
shut-
about earlier.
Let me shut this other one
It
off.
sees the amp clamp, but what it doesn't know is what amperage range you want to use. You have to tell it what you're going to do there,
Green.
or it'll just automatically set for whatever the default is.
Okay, so we got green and that. We're good. No trigger. I'm going to lower this time here. Let's
Yep.
start that baby up.
Wait a minute, I got to put it around the wire.
Oh, the amp clamp. Yeah, I forgot to zero it. Hang on.
Yep, zero it, yep.
Okay, so there's our zero offset.
Okay, so now I'm going to put it around the wire. And I'm going to fire it up, right? I still,
Yeah.
I think, have the red hooked up, so we'll still see the mass air.
Oh, I took that off.
Oh, okay, I guess we won't see the mass air. All right, so I'm going to fire it up, right?
Yep, go ahead. All right, so now I got to trigger off one of them, and that's called walking. You see the signal walk across the screen?
Right.
Nothing steady. So I'm
That-
going to trigger
That's why you want to trigger it.
off the C channel.
And this was, I forgot what injector it was. Number one. It was number one injector. There you go.
I'm going to move it over here, one box from the end, and I'm going to change it from rising to falling, so I'm on the end. I'm going to move the green up, okay? And you could see as the voltage went down right here, this is our system voltage, and if you look over here, 810, you can see where we're at, and here's our current. The current is being read here. If you wanted to take some cursors down and go like this, 922 milliamps. If you wanted to see the peak of the injector that we said 35, you would go like this, and we're at 50, almost 51.
So remember we said 900, we said around an amp for amperage? There you go. And you could use cursors on that to look at the on time as well.
Yeah. So there's the voltage and amperage. And again, you see it's small. If we want this wider, what are we going to do? We're going to go down with the time. Now you see that? When you go down with the time, look at the pintle bump, more pronounced. In fact, if I take the blue line and move it down here, it's going to tell you that pintle is opening. Remember I said about 60%, 600 milliamps? Look at that. Right on the money. Okay? And you look how the injector is being clipped. Look at the square wave up top. Okay? That is being clipped.
And clipping just means that the computer has something in it, a diode or resistor, that will not allow that spike to go over a certain level. It bleeds it off into a ground circuit or a power circuit, Question?
How do you save the data?
Oh, so at the top of the screen is a save screen.
See where my cursor is right now? So if I hit save,
a box opens and
it's going to ask me what I want to save it to.
yeah, and we don't really.
I could pull the vehicle up.
We did this already about 20 times yesterday and
Okay.
today, but you have to pull up everything and you have to fill in the data.
If you want to label the channels,
Yep, it's down below a little bit. Yep, there you
so
go.
I could say channel, what are we on?
The channel A is on the low amp clamp for injector cylinder 1, and channel C is on the voltage. So notice it only shows us 2 channels. It only shows us the 2 active channels. If you turn a channel off, it doesn't show up on that menu.
Which is really nice.
It is actually handy. So you put in, and by the way, I recommend putting as much information in these files as you can, because if you're like me and you have 8 million files, you're not going to remember later. What was the question,
And then
Doreen?
after you add that info, you put save.
What about pintle close? So you're not going to see pintle closing so easily in the amperage,
No.
but you are going to see it on the voltage side. And you'd have to dramatically increase the size of the pull down part of it, or the part after the pull down, to see when it closes. Or when it falls down, I should say, after the spike. Maybe you can expand that part, Jerry. Yeah. Okay, maybe move it over a little.
Let me get back.
Yeah, there you go. Let's do a little more of a box.
Come on. Oh, it's here. That's why. You get that? Go.
A little more over to the side where the power bleeds off, the other side. There, okay. Yeah, like there. You see the bump way over here? That's where the pintle actually closed. Yeah, the little bump. You're not going to see it on the current side.
Yeah, it's probably about the best view.
Yeah, we should blow it up a little differently. But that's what you're looking for. So think about what's going on electrically versus what's going on mechanically. You're turning on the injector by grounding it, right? It had power to it all the time. It's grounded by the computer. The coil energizes electrically and starts building a magnetic field. But it takes a while for that magnetic field to get strong enough to pull the pintle back against the fuel pressure, right? Then, now it's open. But when you release it, you've stopped drawing current, but you still have a built-up magnetic field holding that pintle up, so it takes a little bit of time for it to close, and that's what you see on the voltage side. If you were to blow up the current side, you really don't see it.
And watch what happens if we move trigger out of range. What happened to my picture? It's gone.
You lost it.
The little yellow here is my trigger. I'm up somewhere, I don't know, 80 volts or so.
Yeah, you're above where it's actually happening.
Watch when I bring it down.
There you go.
Okay. I'm going to stabilize it. Now, if I went into trigger, I'm at 8 volts. If I put rising, look at the difference.
It moved over.
And if I went like this to move it this way, you see how that's missing? But if I go into trigger and I put falling, now you can see what's going on. Okay.
You can also change the percentage of the screen over where the trigger occurs.
Right.
You know, 10, 20, 30, 40, wherever you want it.
Yep, your percentages.
All right, so
All right, what are we doing next?
In-cylinder compression, I think.
You're right. Any other questions while we're taking the plug out?
Now, by the way, as a safety thing, I am taking the key out of the ignition and putting it in the console before I do anything else, right?
Now, that is a good move.
Okay. So let me, we've already kind of pre-loosened some of this stuff.
Yeah, we tried to think about, the time that it's going to take to do it. So the bolt is hand tight, so the coil could pop out relatively easy.
Yep.
And obviously you want to disconnect the wires from the coil. You do not want any, you know, flamethrowers per se, right?
No, none of that action. In fact, coil is in my hand. It's not in the car.
Yep.
Not plugged in.
Leave it out.
Yep.
Now we're going to take the plug out.
And it's going to be hot, so, you know, don't lick it.
We got a rag, so when he pulls it out,
Well, actually, we do, but I'm going to use that tool you have so I don't have to touch it with my hand. We'll put it on the rag, but I won't have to touch it with my hand. So instead of a magnetic socket, and don't get me wrong, I like magnetic sockets, or even the rubber, you know, the kind of socket that holds with a rubber seal. But in this case, we have a regular socket. It's not gonna hold a spark plug. And we have this little gizmo here with a little, the same rubber type of thing, but it's got the ability to flex, right?
and that's what you should use to put it in. When you use a magnetic socket or rubber in a socket, what happens, you could easily strip the threads.
Right.
And
So-
also this plug has a little anti-seize on it. When we torque it at, I think this one is 15 Newton meters, when you have any anti-seize on it, sparingly, so you do not get it on the porcelain or on the tip, you got to go down 1 Newton meter.
So I'm putting the adapter in. And actually, before I do that, I'm going to move this wire with the piercing, with the back probe pins there, so I don't, you know, give myself an extra hole or two in my arm.
I'm going to take these off,
Yeah, that's a good idea.
and I'll undo the one on the coil in the back.
Yep. So, you know, this is kind of the setup. Now, you know, we were talking earlier about in-cylinder and hard-to-reach cylinders, but if you have a real problem on an engine, especially a V engine,
You need to have this.
and I recommend testing the suspect cylinder, a good cylinder on the same bank, and a good cylinder on the other bank, especially
yeah.
when you have bank-to-bank timing issues.
We want to show them what we're using.
So this is the
PICO transducer.
WPS 500 transducer kit, right? It has, we didn't know the state of charge when we got it, so we put a USB charger on it just so we, you know, so we wouldn't get through the middle of this and have it die.
Nothing like something dying on
Nothing
you.
like something died in the middle of a video. It has it's already on because it's plugged in. It's kind of automatically on. But if it wasn't plugged in, this red light would be off when it's off, and then you'd hit the power button and it would come on. And there are different sensitivity, let's call them settings, for different types of testing you're doing. We're going to use the position 1 because we're doing in cylinder. But if you were doing vacuum or, say, crankcase pressure, you'd use one of the other settings. Okay, this is just a push-on connector. I'm going to put it on there, and
Okay, we got to set this up. What channel are we on?
tell you in a minute. Where's the end of my wire? This thing has a gigantic wire on it. You could be in the next county with this thing. There we go. I guess we'll take it off of this since we're already here. Let's go on channel C.
C?
Yeah,
CC.
C.
All right, so we want to select probe. We want to go down to this one here, the WPS.
Yeah, there's other sensors, obviously. They have other things that you can buy, but this is the one that we're using right now.
Notice it's 500.
Now, obviously, if you wanted to do multiple signals at the same time, you'd have to have multiple transducers. We're only doing one, but you'd have to do that.
Okay, so we're on. You want to trigger.
Did we take the back probe pin out of the ignition?
I did. You want me to put it back in?
Yeah, maybe so. You know what? You can use this probe because we're already here. We don't really need this other stuff.
course, I need that light down there because I can't see to save my life.
It's the one away from you, right? It's the
one
one towards my side.
Yeah.
Okay. We're talking about this because actually I was the one who did most of that setup, and he might be on the wrong wire. And then it's an ignition coil, right? Oh, actually I need to be on the, I should have been on the green wire. You are on the green wire. I should have it hooked up because it has the attenuator in it. Oh, so we talked about this, but I'm going to reiterate it.
I'm pulling this off to look at the wire pen. Was it the purple one or the one towards you, the white one?
One towards me, the white one.
Let me get in there because I know we had a problem with this before.
So, because an ignition coil can give you a big spike, and the computer can only, or the module, I should say, can only handle 200 volts, and you don't want to smoke your channel on your scope, we're using the attenuator, the 20X attenuator, so that the actual voltage that the scope sees is going to be 1/20th of what the coil delivers in its spike, and the software adjusts that so it gives you the right number on the screen, but the scope isn't wearing all that.
And what channel am I on that?
You're on D.
D, like in David.
The D like in David.
All right, let me get D on.
So that's why we do this. And again, when you're on something that you do not understand, look at the wiring diagram, look at the, it doesn't hurt you to use a 20X attenuator or a 10X attenuator.
Saves your scope.
When you aren't sure what you're looking at. We are sure what we're looking at this moment, so we're going to use it. It's nothing worse than smoking something that you didn't need to burn up. That with a little care you could have avoided. So, all right, so.
Hang on, I'm trying to trigger here.
Yeah, so Jerry's going to have to do some setups because even though it recognizes the, the transducer itself, he's got to set up the stuff for the ignition. That's not automatic.
Yeah, for some reason I can't get on D. It'll trigger off.
Want me to change channels?
It's triggering off the pressure transducer.
I'll put it on A. How's that?
Let me turn that off. Let me go to A. And now one to D.
I love it. This is software stuff, not the actual scope, of course.
I put it back to D. It's triggering on D.
Okay. It's just to keep us all jumping, guys, and keep you waiting.
And where's the pressure transducer on that?
Pressure transducer is on C. And I'm not using A or B. Any questions here while we're doing that? Let's save. How do you save data capture? We showed you that. What is it about pencil close? We did that. Oh, okay, okay. Does the scope know that it's plugged in, or do you select that? No, you have to select that. The scope does not, because the attenuator, that's something you could suggest to them, to make the attenuator something that has the 6 extra pins to the BNC1 system that they have.
Yeah, it's a nice setup.
If they did that, that would be spectacular.
But it's easy enough to do.
Yeah, exactly. But all you have to do is select it. So the attenuator is an extension between the BNC1 and the scope. So you've got to tell it what it is. Doesn't see that connection anymore.
Yeah, you want this at a second, or you want it less? 200 milliseconds.
We're going to be running it. Let's
actually change it once it's running.
Yeah, let's do it a second to start and see what we got.
You got it.
Maybe a couple of seconds. I don't know. All right, I'm gonna. When you're ready, I'll start it.
You say when, sir.
Yep. All right, I am starting it up.
Go.
Now, obviously, it's running kind of crappy because it's only running on 5 cylinders.
Okay, I stopped it.
Oh, sorry. All right. So this is in-cylinder compression and ignition, right?
Yep. Ignition's up top in the gold. And
Now-
here is our,
Mind you, this is
Compression.
really the same setup we had when we showed you that one in the slides. And so the ignition is not going to be just before top dead center for this cylinder because it's actually a different cylinder.
correct. But what we have here is that crank of compression right there,
Yep.
right?
Yep.
And look what happens when we get down to running compression.
And if we let it run long enough, well, actually, it's pretty good there. The
Yep.
running, it stabilizes. If you ran it for a long time, you'd see that it's very stable. If you saw that it was going up and down very rhythmically, very slowly, that's usually a rolling idle. But if you saw one really high, one really low, one,
Valve problem.
now you got a sealing issue, and it can't be a piston because they just can't change that fast. It's got to be a valve sealing problem, right?
Yep.
A valve problem.
Valve problem.
Loose
Some
guide,
sort.
loose guide, carbon in it,
Whatever.
pitted seat,
seat.
whatever. Yeah.
Those 3.6 pentastars, I go, thank you, God. Because they show up bad all the time.
So the bottom line is, as soon as you see this, if you see a real high, real low, real high, real low, whoops, Mr. Customer or Miss or Mrs. Whoever customer, you have a mechanical problem.
And you're not doing this. You're not doing this with your regular compression gauge. It's not going to happen.
Right.
Okay. So keep that
I
in
never
mind.
heard that you could use an attenuator. Does the scope know that it's plugged in, or do you select that? Oh, that's the. Is that the? No, I already answered that. Yeah, no, it doesn't know. You have to tell it. Oh, the comment about anti-seize. Yes, it changes torque requirements. Yeah.
Yeah, you got to put a 1 Newton meter less.
Right.
And do not put too much anti-seize on there. In fact, Ford Motor Company tells you not to do it, but if you want to kind of remove your head and use a helicoil, then it becomes a nightmare.
We
We use copper anti-seize, a very small amount. I'm talking a little dab.
We're going to date
on your
ourselves.
finger.
Again, I'm going to date myself. There used to be a Brill Cream commercial.
Yes,
A little dab will do you. It's the same thing with anti-seize. Just
I don't have enough hair to use that Brill cream on.
actually, I don't either. But but it was a hair gel type of hair cream. Anyway, for those of you who don't know what it is, bottom line, it's just a little teeny bit in the threads to make them so they don't seize and gall. Not enough so it creates a problem.
You bet. All right, we're going to finish some stuff up. We're going to put the plug back in. Well, actually, they don't need to see that on camera.
No, that's good. We can do that
We'll
afterwards.
shut the fan. I'll shut that light back there.
Yep.
And the upper switch, Pierre, first shut, so don't put glare on us. We're going to go to us with slides, and we're going to do our thank yous. All right, so we do have a question.
Oh.
Did we give you some insight into using a scope? Okay. And we can't answer that other question you just asked. If we gave you some insight, I want you to take your scope. Hopefully you have a PICO, but whatever you have, you need to take it out and use it. Same test we performed here on the battery with voltage and amperage. You could do that. You could see if you got a bad battery. Now, when the voltage falls, we should really say this because it's a lot faster. So if you had a lead acid battery, which is 2.1 volts per cell, 12.6 should be the full charge.
At room temperature.
Right. Now, if it goes under 9.6, that'd be okay. Most of what you're dealing with now are EFBs, which is enhanced flooded battery, and AGMs. Come on, almost every car in their mother has an AGM.
All the ones I work on have AGMs.
Yeah, because they put them all inside the car.
Right.
We get a load of them, and even the little battery, the backup battery, or sometimes two big batteries, AGM, you're going to be about 12.8 to 13 volts. That means your voltage should not fall under 10.1. But
You're
using
talking
a
about
scope-
as you crank it, right?
As you crank it.
Cranking voltage.
on the load. Now, if you're using a scope, 8.5 volts, the voltage drop is okay. Why?
But it's very quick.
It's quick.
Yes.
It's a difference. So write that down, 8.5 volts if you're using a scope. If you're using your AVR or volt amp doohickey, a
Multimeter.
meter type setup on min-max, it's not fast enough to give you a reading like that.
Right.
Okay, so a scope is a great thing to do. Use it, first of all, let's say with cam and crank, you get a P0, 0, 11, 13, 21, 17, all of those cam crank codes, the intake to exhaust. What a better way to do it than back it up with a scope.
Right. And by the way, we didn't do this tonight, but there are files online where you can get known good references, or we really recommend when you get a known good car, make
Take
your
it.
own
You bet.
library.
Yes.
Take your own measurements. First of all, it makes it so you know how to do the test. Number two, you have a known good for that car that you work on regularly.
And let's go over this.
And I want to add something to that.
Sure.
That cam crank is at idle. If you want a real test, you should pull your scan tool out and force the cams to advance and retard while you save that data. Now you have a range of motion, and you can tag it to an RPM.
Yeah, so if you get a new vehicle in and you got some time, do it. Or at night, stay after work or lunch or early in the morning, save some of the files. Now, if you're not on IATN, okay, or diag.net, they got good file stuff. And I know on Facebook, PICO has a really nice setup where there's a bunch of people that are using PICO scopes with very, very helpful information. We just did one with my buddy Adam Robertson. He's Mr. PICO himself.
Yeah. Way
you
better
gotta-
at it than I am, I'll admit.
He plays with that every day. We use a bunch of different stuff, but PICO is a very good scope, as you can see, and it does a lot. So we want to thank PICO for sponsoring this Motor Age TST. We will ask you we'll answer some questions, I should say. This will be up tomorrow morning on the TST website. I will make sure it is up there. The handout will be there. And Motor Age, where you signed up, it will be up on their website. So those are two places you can go. If you have further questions, you could email me at TST, GT, Doreen will type it in there, gt@tstseminars.org. And Pierre and I will get back to you on what your question was and the answer. Again, it has to pertain to PICO, right? Mm-hmm. Don't ask me about how to get to the moon. I have no clue.
Or what the weather's going to be next week, because nobody has any clue about that.
Now, if you thought we were helpful, okay, and this helped you, please type the letter Y in. If you think we sucked, type the letter S in, okay?
So there's some
And
questions.
by the way, we'll be back on May 6th.
Right.
For another Motor Age TST webinar on suspension with, I better not mention it because I'm not sure who the sponsor is, but that doesn't matter.
What were the questions?
Yeah, why does scope flash over range when running tests?
If it's over range, it's because you set a voltage
volt
too
too
low
low.
for the actual voltage of what you're seeing. And that can happen even if you think you're okay. You're on a 20 volt, 14 volt circuit, you got 20 volts. But what if, say, the ignition system is spiking something into that system and you have something higher than that? It'll give you an overrange. It'll tell you you're above what you've selected.
And by the way, if you see overrange, you probably do not have the attenuator on it.
Yes.
So please, if you're doing anything that spikes, definitely ignition, and I don't care if it's primary or secondary.
And injectors.
And injectors.
Anything
And-
with a coil, actually.
Yep. Make sure you got a good ground. I mean, you could get a purge solenoid to go wacky.
Yeah, it's got a solenoid in
Transmission
it.
solenoids.
Yep.
Anything with a steel bar with windings could do some damage.
spike it
to
and smoke it.
the scope.
Same person that asked that question said it did it while you were demonstrating.
Yeah, we probably had it set something not quite right, or we might have had spikes. But yes, it
It's
overranges.
possible.
It overranges when your setting is not up to whatever the signal is.
And remember, there's 10-to-1 or 20-to-1 attenuators
Right.
that are out there.
And I want to add something to this. This is true of all
Oh, and I wanted
scopes.
to show the paddle while you
But-
were adding that.
Oh yeah, but you have to watch what other interference sources are near you. If you just have your wires there and you see something that looks like a sine wave and nothing's even running, you better put some cursors on that and find out if that's 60 hertz, because you could be picking up house current off your lights or a drop light or an extension cord you have near you, and that's going to confuse you. That's not even the car doing that.
And you shouldn't really be using any drop lights.
You shouldn't be using anything plugged in.
We have them, you know, that plugged in. They're all fluorescent, not the cage burners to burn your arm.
Yeah.
Okay, those definitely should
I knew
not
of
be
a shop
used.
that blew up years ago because of that.
I know a couple of them.
The guy dropped a drop light, an old light bulb drop light, and they had a gas tank out of a car and it was open. Burned the whole
Boom.
shop down.
Oh, yeah. There was-
Killed somebody in the back of the shop too.
Yep.
Terrible.
So be very, very careful. There's so many lights. I mean, my guy's I have the ones
headlights.
that go on your head. I have tons of lights. So
And
my
even a
light
little
under the
LED
hood,
like this.
I love those. I
Yeah,
keep
these are
that
nice.
when I'm working. I leave it in my pocket.
I have a handful of these because, you know, I always forget to charge them.
Maureen will tell you, I just love flashlights, so I buy everything.
But you know
But
what?
anyway.
They're handy.
Collection.
Yeah,
One last thing. This is really good. This is a PICO paddle, which we didn't show you, but basically we showed you ignition. This is for secondary. Look at the paddle part here. So if this is the coil, I would go like this and I can get a reading. It's really, really a nice setup.
Very sensitive.
And look, it's sensitive and it's bendable.
So remember
you
that
can put it
fold-over
everywhere.
manifold that you can't reach the ignition on?
This
You can
is it.
probably reach that coil with this guy.
Yeah, so the PICO kit that you see behind me here, that has all this in it. They even have wires. We talked about the plug setup.
The extension wires for the,
The extension
ignition.
wires. They thought of everything, sticking it in there. They also have a high voltage kit that we don't have here. So check that out. There's
They have
Justin
they have
that works for
NVH
them.
too.
Yeah, they got some good tech support help. So Craig runs a lot of the PICO stuff throughout the country. And you could always contact PICO, go to their website, and they have some good information there as well. And I want to say, on behalf of Motor Age and TST, I want to thank you guys again, especially on a Saturday night coming out. Okay, we'll see you on a Wednesday night, I believe, coming up.
It's
for
the 6th
next
anyway, yes.
Yeah,
I think it is a
next Motor
Wednesday.
Age
The 6th.
TST webinar. Thank you again from New York. I'm G. Trulia, and
And I'm Pierre Respo.
thanks again. Good night.